This is review number 1 for chapter 6. The directions say for exercises 1 through 7, triangle PQR has vertices as shown. Number 1 wants us to give the coordinates of the triangle. So P is right here, and we're just going to read those coordinates. That's -1, 1. R is over here. It's 3, 3, and Q is 4, 1. Okay, number 2. If the figure is translated 6 units down, what are the new coordinates of R prime? Well, 6 units down means I want to take away 6 from the y coordinate. So I'm going to write down my regular R here. My regular R was 3, 3. And I want to take away 6 from the y coordinate. And of course, you know, xy is like this. So we're taking away 6 from the 3. So R prime is 3, 3 minus 6 is -3. And I always do it here. When I show work, you should be showing work as well, just so that it's easier for you to see, because I easily get confused. Okay, so here we're looking for 3, -3. All right, which is answer B. And see how the answers are all very similar, so be very, very careful when you're doing this review as well as the test. Number 3, if the figure is translated 1 unit to the left and 2 units down, what are the coordinates of Q prime? Well, let me start with Q, and I'm just reading it from above here. That is 4, 1. And of course, 1 unit left, that's talking about the x. I want to take away 1 from the x. And down is talking about the y, and that's subtracting the 2. So from the x coordinate, I want to take away 1, and from the y coordinate, I want to take away 2. So Q prime is, let's see, 4 minus 1 is 3. 1 minus 2 is -1. Again, all the answers look very similar, so be careful. I want answer G. All right, number 4, if the figure is rotated 270 degrees clockwise about the origin, what are the coordinates of Q? Okay, I'm going to do this one 2 ways. If we use our graphic organizer that gives us a formula of what to do, we're looking for 270 degrees clockwise, which is of course the same. Let's write this down. 270 degrees clockwise is the same as 90 degrees counter clockwise. Can't fit it. Okay, so that formula from our graphic organizer under rotations says the xy changes to -y, x. So if I use my coordinates of Q, because we're asking for Q prime, Q is 4, 1. Let's write this here. Q is 4, 1. Therefore, I'm going to switch the x over here. Forgot to end my parenthesis. Okay, I want to put the x in the other place. Okay, so the 4 needs to go over here. Okay, and that stays the same sign. And then we can change the y and put it in the x spot, but make it the opposite sign. So here's the y. Sorry. Okay, here's the y. I want to put it in the x spot, but I want to change its sign. So instead of 1, it will be a -1. Okay, that's one way to do it. Now let's just double check the other way. A lot of people, you've been doing it this way this year. If I want to go 270 degrees clockwise, that's 3/4 turns, right? So I take this, just slide it down a little bit. There we go. I need to do it 3 times. 1, 2, 3 times. Okay, and then I read my new coordinates of I want Q prime. So this is at, let's see, this would be a -1 on the x-axis and a +4 on the y-axis. And as you can see, our 2 answers are the same. -1, 4. And so that is answer D. All right, if the figure is reflected over the y-axis, what are the coordinates of P? P prime. So the y-axis is of course this axis. So I'm reflecting it over that axis. So P just gets put over here. That would be your P prime, and the coordinates of that would be 1, 1, which is answer I. For those people that want to think about it the algebraic way, when we reflect over the y-axis, the y stays the same, and the x gets made opposite. Which if you look at P, the y coordinate stayed the same, and the x became the opposite sign. Okay. If the figure is dilated using a scale factor of 3, what are the coordinates of r prime? Okay, so let's write r, which is 3, 3, and we want to dilate it by a factor of 3, which means multiply by 3. So 3 times 3, and 3 times 3 gives us 9, 9. Okay, number 7. Now reflect it over the x-axis, and what are the coordinates of Q prime? So here's the x-axis. So reflect it. Okay, here's Q. It's got to be 1 above, so you go 1 below for Q prime. And that coordinate is, let's see, 4, -1. Okay, and of course the x-axis means the x stays the same. As you can see, my x stayed the same, and the y became opposite. Okay, number 8. New stuff now. We're on the back. Triangle LMN has vertices right here, L, M, and N. What are the coordinates of the image of point M? So we're looking at M after a dilation with a scale factor of 3. Well, we just talked about what that meant, so let's write down M. You're writing this down with me. And we're multiplying by 3, so times 3 times 3. So M prime is just -2 times 3, which is -6, and 4 times 3 is 12. Be careful, they all kind of look similar. This is answer A. Triangle RST has vertices here, R, S, and T. What are the coordinates of the image of RST after a translation 4 units left and 2 units down? Well, 4 units left means we're going to take away 4 from the x-axis, and 2 units down means we're going to take away 2 from the y. So we're looking at RST. Let's just start with R. Okay, here's R. Original is -1, 1, and we're going to subtract 4 from the x and subtract 2 from the y. So R prime is -1 minus 4 is a -5. 1 minus 2 is -1. Let's see if we can answer it from that one. All right, it's not F because that has -5, +1. It could be G, can't be h, and it could be I. So let's keep looking because we're not done. All right, somewhere where you have room, let's write down s. All right, we have 3, 1, and again, we want to take away 4 from the x and take away 2 from the y. So s prime is going to be 3 minus 4, which is -1, 1 minus 2, another -1. So the only one that has r prime correct and s prime correct would be this one. So your answer is I. See, this one doesn't work. All right, we have a quadrilateral four-sided figure with vertices W, X, Y, and Z. What are the coordinates of the image of point W after a reflection across the y-axis? Well, let's see. Let's write down W. We have -3, 4. When we reflect over the y stays the same. Okay, and the x becomes opposite. So the y is going to stay the same. So this becomes a 4 still, and the x just becomes the opposite sign. If you want to, you could graph it on graph paper, but that's how you would do it without graph paper. So 3, 4, which is answer A. Okay, number 11, we have triangle PQR. What are the coordinates of the image of point P after a triangle is rotated 180 degrees clockwise about the origin? Well, when we rotate 180 degrees clockwise, we have a rule. 180 degrees, this comes from your graphic organizer. So take that out, pause the video if you need to. Find the rule for 180 degrees. Well, this says that x, y becomes, I'm going to write it down here because I'm running out of room, -x, -y. That's all we got to do is change the signs of x and y. So we're looking at point P. Point P, I'm just getting from up here, is 6, 5. My rule says to make x and y opposite signs. So this is going to become -6, -5. -6, -5, be careful, they all look the same. There it is. All right, the graph shows segment M prime N prime is a dilation of segment MN. What is the scale factor? They're saying that we start at this one. The red is where we start. Okay, we know this because it does not have any primes. Okay, we know the other one has some primes, which means we end there. So we're getting smaller, right? And to find out how much, we're just going to use some points. Let me use a different color here. So if I take, let's do green. If I take the original point right here, that is the point, let's see, 0, comma, where's my axis? 1, 2, 3, 4, 5, 6. 0, 6. And that's becoming this point in the new figure, which is 0, 3. So what do? What do you multiply by? Because dilation is multiplication. What do you multiply by to get from 6 to 3? If that confuses anybody, go backwards for a second. From 3 to 6, you multiply by 2. But since we're making it smaller, it's really 1/2. Okay, think about that. If you multiply 6 times 1/2, I get 3. Half of 6 is 3.